Today we're going to be talking about solving a quadratic equation by the quadratic formula. We're going to start first with vocab. Our standard form quadratic equation is y equals ax squared plus bx plus c. We've been seeing this for several lessons now. Remember, a, b, and c are all numerical values. Next, we have the quadratic formula. This is in the formula of x equals negative b plus or minus the square root of b squared minus 4ac with the entire thing divided by 2a. This is just another method that helps us find our solutions or our x-intercepts of a quadratic equation. We're going to start first by just identifying what our a, b, and c values are, because this is really important in being able to use the quadratic formula. So first thing we have to do is ensure that our equation is equal to 0. If it is not equal to 0, it's impossible for me to list my a, b, and c values correctly. Then I'm just going to pull each of those values out. So let's look at number 1. You can see in this equation that it's equal to 0, so I'm ready to go ahead and identify my a, b, and c. My a value is the value that's in front of the x squared, which is 5. My b value is in front of the x. You must take the sign with it, so that's a negative 12. And my c value is the value that has no variable at all, which is 9. All right, let's look at number 2. You can see that this equation is set equal to 0, so that's great. You'll notice that this equation looks like it's in a different format, so we could actually rewrite this if needed to help me find the a, b, and c values. So I'm going to take that first term of negative 2x squared, and I'm going to write that first. Then I'm going to take my next term of 8x and write that second. And my whole number that has no variable at all will be my third value. Notice I took the signs that were in front of them with them. So that would make my a value negative 2, my b value a positive 8, and my c value a negative 4. All right, number 3. On this one, it is not set equal to 0. So that's the first thing I have to do is I have to get 8x to the other side. Remember, we do this by the inverse operation. So I'm going to subtract 8x from both sides of my equal sign. That is going to give me 3x squared. I'm going to plug that negative 8x in the middle because that's my b term. It's the one with the single x on it. And my plus 9 in the back. Now I can see it's in my standard form. A is a positive 3, B is a negative 8, and C is a positive 9. You'll notice that if I wouldn't have started by getting my equation equal to 0, I would have thought my B term was a positive 8, and it's actually negative, so that's super important. All right, on number 4, it is equal to 0, but you notice I'm missing a term here. I'm missing that B term. Remember back to when we factored, we can add a 0x in the middle of that equation. So now it looks like it's in standard form. I'm ready to identify. A is the coefficient of x squared. It is not the x squared. There will never be an x as part of the a value. It helps me determine which numerical value is a, but x squared is not a part of the a itself. The a is the number in front, which would be a coefficient of 1. B would be 0, and C would be negative 4. All right, now that we have practiced just identifying A, B, and C, we're going to actually put that together with plugging in my A, B, and C values to my quadratic formula and solving. So I'm going to do those same first steps first. I'm going to make sure it's equal to 0. It is not. So I'm going to subtract 2x to move it to the other side of my equal sign so that my equation will equal 0. The negative 2x is my b term, so I'm sticking that in the middle. That would give me a as a coefficient of 1, b is negative 2, and c is negative 8. All right, next I'm ready to plug this into my quadratic formula. My suggestion is to write out my quadratic formula with my variables, and then I'm going to change my variables to include those values. So right now I just wrote it out exactly as I would see it on a formula chart. Now what we're going to do is I'm going to do what I call erase and replace. So I'm going to erase this b value and I'm going to replace it with the b value of -2. When I plug it in, I do need to put it in parentheses. Super important, because you'll notice a lot of people would actually drop one of those negatives by accident. So it's really important that I leave it inside those parentheses. Okay, I'm going to erase this b term, and I'm going to replace it again with another -2, and it has to be in parentheses, because remember, a -2 inside parentheses squared is different than a -2 squared with no parentheses. All right, now I'm going to erase my a, and this time I'm plugging in the a value of 1, again inside parentheses, and erase a c value of -8. Then the denominator, erase my a and replace it with an a value of 1. Now I am ready to start solving. So when I do this, I'm going to break my problem into 3 sections. Section number 1 is going to be the part in front of my plus minus sign. So what I'm going to do is I'm going to simplify this -2. Well, we know that 2 negatives will give me a +2. Bring down my plus or minus and bring down my radical. Now, I am just going to do the part that's under the radical. So when I type this in, I will not type that square root sign. I'm only typing what is underneath. So in your calculator, you'll type in parentheses -2, close your parentheses, squared, -4, parentheses 1, close your parentheses, and parentheses -8, close your parentheses. When you type that entire thing in your calculator, you're going to get the value 36. I did not actually do anything with the radical yet, so I just brought that down. My third section is going to be the denominator. So I'm going to do my 2 times 1, which gives me 2. So now I'm down to this problem. Now I'm going to simplify the radical if possible. So I'm going to check my square root of 36. That can break down to the whole value of 6. So I'm going to rewrite this problem again, and instead of the square root of 36, I'm going to say that's equivalent to the whole value 6. If needed, you could come over here, make your factor tree, say 6 times 6, 2 times 3, and you can see that it creates a set of 3s and a set of 2s to pull out. There's nothing left, so there's no radical left. So you can always break it down with the factor tree if you need to. Now that I'm here, I'm going to break this into 2 chunks. I'm going to do 2 plus 6 divided by 2. And then I'm also going to do it again, but this time with my minus. And then I'm going to solve these problems. So if I look at this, 2 plus 6, that will give me 8. And 8 divided by 2 would give me 4. On the other side, I would do 2 minus 6, which will give me -4. And divided by 2 would give me -2. So this tells me I have 2 solutions at +4 and -2. You can envision what this would look like on a coordinate plane. It would look something like this, going through at +4 and -2. Again, I could check this. I could plug it into my equation, each value, and make sure it works. I could also graph each one of those to make sure that it works as well. All right, let's try another one. Looking at this equation, it is not set equal to 0, so that's the first thing I'm going to have to do is move this 7 over by subtracting 7. That gives me 6x squared minus 11x minus 7 equals 0. Identify your A, B, and C values. So A is 6, B is negative 11, and C is negative 7. So now I'm going to write out my quadratic formula. If you don't want to do erase and replace, what you can do is write out your formula, but instead of variables, you can put in parentheses instead. So I'm setting up my formula, but with just sets of parentheses instead. So my first two parentheses are my B value, which is negative 11. My third parentheses would be my A value of 6. That also goes in the denominator. And then my last one is my C value of negative 7. Now that I have everything plugged in, remember I'm going to break it into 3 pieces. I'm going to start first with the part that's outside in front of the plus or minus. Since there's 2 negatives, it's going to become a positive 11. Drop down my plus or minus. Now I'm going to do the part under the radical. Remember, I'm not going to type the radical in yet. And that's because it may not come out to be a nice value. Okay, I'm going to plug in everything underneath the radical sign, and that's going to give me 289. Then I'm going to do my denominator of 2 times 6, and that's going to give me 12. Once I get here, I can check to see, does the square root of 289 come out nicely? Is that a perfect square? The answer is yes. If I type that in my calculator, it gives me 17. So I'm going to change that to a positive 17. Once I take the square root of 289, the radical goes away, and all I'm left with is whole values. All right, now I can break this into 2. So I'm going to say, in the first one, I'm going to come up here. I'm going to say x is equal to 11 plus 17 divided by 12. Well, 11 plus 17 is going to give me 28. And 28 divided by 12, now you can leave this as an improper number, which would be 7/3, or you could write it with a repeating bar since it does repeat. Either one of those is fine. Don't forget my second solution. I have to rewrite, but this time with a minus 17. So then I do 11 minus 17, and that gives me a negative 6 over 12, and that can simplify to negative 1/2, or if you want to write it as a fraction, you can say negative 0.5. So I have 2 solutions, one at 7/3 and one at negative 1/2. Okay, let's look at a couple more. Number 3, we're going to start first, make sure it's at equal to 0. It is. We see that we're missing a term, so I'm going to rewrite that with a 0b in the middle. Now I can identify my A value as 1, my B value as 0, and my C value of negative 25. Then I can come down here and write my quadratic formula. Again, you can either erase and replace, or you can set it up with just parentheses that you can fill in. Now, the nice thing about the quadratic formula is that it will always work no matter how ugly our answers are. And so that's one of the beautiful things about this method. All right, remember the first 2 parentheses is my B value, which is 0. The next one's my A value of 1, which also goes in the denominator. And my last one is my C value of negative 25. We're ready to break it into our 3 chunks. First, we have a negative 0. Well, that's not a thing. And we don't technically even need 0. If you want to leave it there, that's fine, but you don't really need it there. Then I'm going to do the part underneath the radical, and I'm going to type it in my calculator to get the answer of 100. And then I'm going to do my denominator, and I get 2. Then I'm going to check to see, does my radical come out nicely if I type in the square root of 100 in my calculator? It will. That will come out to be 10. Since it's not a decimal, I don't need the radical anymore. All right, now I'm ready to break it into 2. Remember, I'm going to do the first one with a plus 10. And then I'm also going to do one with a minus 10. Well, 0 plus 10 gives me 10, and 10 divided by 2 gives me a solution at 5. For the other solution, I do 0 minus 10, and I get negative 10 divided by 2, which gives me a solution at negative 5. So I have a solution at positive 5 and negative 5. All right, number 4, we're going to start first by getting it set equal to 0 by moving that 6 to the other side. I'm going to subtract 6. It has to combine with its like term, which is the negative 4. So that's going to give me 3t squared minus 12t minus 10 equals 0. So now I can see that my a is 3, my b is negative 12, and my c is actually negative 10. So now I'm going to come over here and I'm going to set up my quadratic formula. So I have my parentheses, and I'm leaving space where I can fill it in. All right, my b value is negative 12. That's the first 2 parentheses. My a value is 3, and that goes there and on bottom. And my c value is negative 10. We're ready to break it into chunks. We have that first section. A negative 12 will give me a positive 12. The part underneath my radical, that is called my discriminant, by the way. There's a name for that. If I type that into my calculator, I'm going to find that it will equal to 264. And then I'm going to check the denominator. 2 times 3 gives me 6. Now, when I type in the square root of 264 to my calculator, you're going to notice it doesn't come out nice. This one is a decimal. So this is going to require a little bit more work than some of those other problems. First thing I'm going to do is break it down with a factor tree. So I'm going to say 264, 2 numbers that can multiply to give me that are 8 and 33. Remember, if you're unsure of that, you can always type in your calculator y equals 264 divided by x to help find those 2 factors. I can break 8 down to be 2 times 4 and 33 down to 3 times 11. All right, one more step. A 4 can break down, and it can break down to be 2 times 2. And I'm just dropping all the other prime numbers down. So I can see that I actually have a set of 2's to pull out. So that would give me 2. And then I have a 2, 3, and 11 left. And so if I multiply those back together, that would give me 66 left under the radical. So now I'm going to rewrite that problem, replacing the square root of 264 with 2 root 66. So I have x equals 12 plus or minus. Now remember, I broke it down to 2 root 66, 6. All right, once we are here, we're going to look to see, can we simplify the outside values? So that would be 12, 2, and 6. Now, you cannot simplify one of the numbers on top. You would have to simplify both of the numbers on top by the number in the denominator. So in this case, they all are divisible by 2. So I'm going to divide every single one of those by 2. That is going to give me 6 plus or minus 1 square root of 66 over 3. Now, technically, I don't really need my 1. So you could get rid of it. This is our exact answer. If we wanted to find the approximate answer, up to this point, there hasn't been an approximate answer because we've gotten an exact value every time. But if I want to find the approximate value of this, what I would do is split it into 2. So I'm going to do 6 plus the square root of 66 divided by 3. When I plug that in my calculator, I get the value of approximately 4.71. Then I would also do the other one, and I would do 6 minus the square root of 66 divided by 3. That would give me an approximate value of negative 0.71. Those, again, are my approximate values. You can write your exact answer all as 1 up here in this box. Or you could even separate it to be 2 separate answers like that. And then here's our approximate answers that are our decimals. All right, we have one more problem, and it's a word problem. Don't get scared because it's a word problem. It's not going to be bad. The calculator is going to do all our hard work for us. All right, first up, it says, in the sports shot put, an athlete throws a heavy metal ball through the air. The arc of the ball can be modeled by the equation y equals negative 0.04 x squared plus 0.84 x plus 2, where x is the horizontal distance in meters from the athlete and y is the height in meters of the ball. How far from the athlete will the ball land? Part A wants me just to draw a picture to illustrate the problem. So here is my lovely diagram. I am a stick figure kind of gal. There's my little athlete. He's holding a shot put. Now, when you throw the shot put, it's going to go up a little bit before it comes back down to the ground. So you can see it kind of makes that parabola shape. Now, what we are going to do is we are going to solve this by quadratic formula. My equation is set equal to y. That is the same as set equal to 0. So I'm good there. I am ready to identify my a, b, and c values. A is negative 0.04, b is 0.84, and c is 2. I'm going to set up my quadratic formula, putting parentheses in place of my variables. All right, so my b value is 0.84. That's the first 2 parentheses. My a value is negative 0.04. That goes the next parentheses and the denominator. And c is 2. Again, we're going to just break it into my 3 chunks. This would be negative 0.84, nothing I can do there. Plus or minus, I'm going to type in what's underneath the radical. That is going to give me a 1.0256. And then I'm going to do my denominator, and that is going to give me negative 0.08. Now that I'm here, these are not really wanting an exact answer. It wants more of an approximate because we're talking about a real life object. So what I'm going to do is split these into 2, one with my plus, the square root of 1.0256, and then I'm just going to type that in my calculator. That's going to give me approximately negative 2.16. Then I'm going to do one with my minus the square root of 1.0256. And when I type that in my calculator, I get the answer of 23.16. Now I want you to think about this. It does not make sense to have negative distance or negative time. So therefore, this answer doesn't make sense. That's basically the shot put where it would have ended if it went back this way. Well, that's not what I'm looking for. I'm looking for where is it going to end on the ground in front of him. That is going to be that second answer of 23.16 meters.